Hi everyone, in this video we're told to simplify the following and state any restrictions on the variables. In the last video we looked at how to simplify rational expressions and the fact that we need to state restrictions on variables before we reduce the expression. So here we've got x cubed plus 7x squared plus 2x plus 14 divided by x plus 7. So the first thing that we're going to look to do is figure out what the factors of the numerator are, and the denominator only has one factor, which is just x plus 7. So notice that there's 4 terms in the numerator, which implies that it might be pretty difficult to factor this using guess and check, or maybe not difficult, but it's just going to maybe take a bit of time. So I might want to employ a different strategy. So anytime that there's 4 terms and you're asked to and you're looking to factor a polynomial, try to implement a grouping strategy. Sometimes it works, sometimes it doesn't. So here we've got x cubed plus 7x squared plus 2x plus 14. Let's group together the first 2 terms and common factor out x squared. So we get x squared times x plus 7 plus 2 times x plus 7, where I've common factored 2 out of the second 2 terms. So in the denominator I've still got x plus 7. So notice that now that I've grouped this, there's a common factor of x plus 7 in the numerator. So I can common factor that out, and I get x plus 7 times x squared plus 2 divided by x plus 7. Now, there's a factor of x plus 7 both in the numerator and denominator, and I gotta remember to write out my restriction that x cannot be equal to -7 before I reduce it. So I can reduce this by dividing out this factor of x plus 7. And this now reduces to x squared plus 2, where I have the restriction that x cannot be equal to -7. In example B, I've got x squared plus 2 over 3x to the power 4 plus 8x squared plus 4. So again, first step is to try to factor the numerator and denominator. In the numerator, I can't factor x squared plus 2. In the denominator, I can factor this using guess and check. So I need 2 values in these places that multiply to 3x to the power of 4. So let's try 3x squared and x squared. And I need a value here and here that multiplies to 2 values that multiply to positive 4. So let's try positive 2 and positive 2. And now I have to check the middle term to make sure I've factored correctly. The middle term is 8x squared. So I've got to make sure that 2x squared plus 6x squared is 8x squared, which it is, because I've got 3x squared times positive 2 plus 2 times x squared is going to make the middle term, which is 8x squared. So I've factored correctly. Now, I've got a factor of x squared plus 2 both in the numerator and denominator, which will divide out. And I need to think about what my restrictions are in this case. So are there any restrictions? Well, if I think about x being x in terms of only the real numbers, meaning x can be rational and irrational, an integer, or it could be 0, which is 0 is also an integer. I can only get a positive value for x squared plus 2. And I can also only get a positive value for 3x squared plus 2. So 3x squared plus 2 is always going to be greater than 0, and x squared plus 2 is always going to be greater than 0 as well if I only consider real values for x. So there's actually no restrictions on the variable here. So this just reduces to 1 over 3x squared plus 2. if I consider the complex, if I consider the case where x can be complex, then there would be restrictions, because I know that if I plug in like, I don't know, 2i here for x squared, well, I'd get 2i squared, or sorry, root 2i would be, let me write this down. If I had root 2i, well, if I squared that, I would get that this is equal to minus 2, and then in the denominator I would have minus 2 plus 2, which would give me division by 0. So I'd have to write that restriction down if I were considering imaginary and complex numbers. But here we'll say that x is an element of the real numbers, but not an element of the complex numbers. So this rational expression reduces to 1 over 3x squared plus 2, and there are no restrictions on the variable.